Okay, so on this one, the first thing we need to realize is we're going to deal with inequalities. So I've written the inequalities down. So this is a greater than. This is less than. Because we always go left to right. So this is like x is bigger because it wants to eat the bigger one. So that's how I know this is a greater than. X is less than. So this is smaller because the alligator is eating the bigger stuff over here. So this is greater than or equal to. And this is less than or equal to. So you probably already knew that, but the important part when it comes to graphing is these are dotted lines, okay? So when you go to graph anything that has a greater than or less than, it's a dotted line. What that means is we're getting right up next to it, but we don't actually include that point. Whereas these ones are solid lines, okay? So if I have x is greater than 3 on my number line, that's a really great number line. There's x equals 3, and it's dotted. And greater than 3, well, the 4 is bigger than 3 and 5. So I shade everything to the right of that line. And this shaded area is my solution because all of these parts have x values that are bigger than 3. So if I have like y is less than or equal to negative 2, so negative 2 is down here, that's going to be a solid line. And less than negative 2, well, that would be negative 3, negative 4, negative 5. So it's all of this stuff shaded down here. Okay, so when I'm even graphing y is greater than x, for example. So that means I go at 0, I go up 1 over 1, up 1 over 1. It's a dotted line. Well, which way are the y values bigger? The ones on the top or the ones on the bottom? These are negative y values. These are positive y values. So these are bigger. So this is where it would work. An easy test is that you can do is to pick a number. So here's a number right here. X is 0. Y is 2. Well, is the y value bigger than the x value? Is 2 bigger than 0? Yeah. So any point that I plug in along here, I could pick any point. You know, x is 1, y is 2. Yep, y is still bigger than the x. So you can pick a point. Now, if I pick any point down here, it's not going to work. So that's 1, 0. 0, 1. Is 0 bigger than 1? Not that I know of. Maybe you know new math. But anyways, that didn't work. So if I pick a point down here and it doesn't work, none of these points will work. And so that's kind of how we shade these. And the shaded area is the solution. Okay, so a solution to an inequality is the shaded area. So the shaded region is the solution. Okay, a solution to a set of inequalities is the intersection of the shaded regions. Okay, so if I have two equations like y is greater than x plus 3 and y is less than negative 2/3 x plus 6. Hopefully this works. It'll work for something, one way or another. So I grab my coordinate axis. Y is greater than x plus 3, so I'm going to come up here. Okay, so I'm going to come onto here, plus 3, up 1 over 1, up 1 over 1, dotted line. Greater than, shaded above. Okay, now I come to the next one, less than, so I come up here to 6, so 3, 4, 5, 6, Better use a different color. Pink. Now I'm going to go down 2 and over 3. Down 2, over 1, 2, 3. Down 2, over 3. So now it's less than. So, whoops, you're not supposed to go outside the line. So that's what it looks like. So the only place where the intersections are shaded, or where they intersect, is this area. So this, anything that's in here, is the solution to the system of inequalities, because any point in here will work for both of them. So the points in this area work for the bottom one. The points to the left over here, they work for the top one, but the points in this area right in here work for both of them. So that's why this is the solution. The part where they both intersect is the solution. Any point in here, I can plug it in both of these equations and it will work for both of them. Anything outside of this yellow highlighted area will not work for both of them. Okay, here it works for the top one. Here it doesn't work for either of them. Here it works for the bottom one. So when it says draw a solution to a set of inequalities, this is the solution where you draw and say, this is where they intersect, this works. Now, just in case you're wondering, you can do this on a calculator. Okay, so I come to my calculator, y is greater than x plus 3. I go to my y equals. On yours, you're going to move it over to the left, like right here, and it's going to highlight the whole thing. Okay, and then you're going to hit enter. And then you're going to have an option right in the middle. Mine doesn't have it, but you're going to have an option right in the middle to toggle through the different inequalities. You can go less than, greater than, equal to. Okay, so yours will have that option on it. So make sure that you realize that mine doesn't bring it up. Okay, but then you just type it in as you normally would. So I changed calculator model so you can see y is greater than x plus 3, y is less than negative 2/3 x plus 6. Not quite as clear as the other model, but anyways, you can. This is how you'll type yours in, and you'll hit graph, and it'll graph it for you. But realize this is the only area where both of them are shaded. Okay, so that's why this is the solution to what we're looking for. So anyways, that's how you're going to do that kind of a problem. And then on yours as well, when you go to second trace, you're going to be able to look at some different, I think you can move it over one, and it'll talk about the inequalities. And you can do inequality intersection and some things like that, and it'll clear off your screen for different things. So anyways, go ahead and play around with it a little bit, and you can find where it'll just show you where the intersection of the inequalities is, or you can just leave the picture and realize that you're just looking for this part, okay? So that's how you can do that on the calculator. Now on this one, since it's a y equals, you can do that on your calculator, or y is less than. So again, you can go to your calculator, go to your y equals, change that to an inequality. Like I said, this model of calculator for some reason won't let me do that. But then you're going to type in the absolute value. So you hit math, number, abs. Okay, and you're going to type in x plus 3, x plus 2 minus 3. X plus 2 minus 3. Okay, and you'll have the inequality, so you'll know which way to shade on this. But it's going to have the picture, and because it's a less than, you know it's going to be dotted lines. So it'll actually draw it for you on the calculator, and they will already be, it'll already be dotted, it'll be shaded. The whole works will be done for you, okay? So left 2, down 3. So y is less than, so that's shaded below. Okay, but on this one, it won't do an x is greater than the absolute value of y minus 2. Maybe it will, I just don't know how to do it. So you guys can learn how, but I don't know how to do that. So what I normally do is I make a table. And I'm going to pick my y value, not my x value, because it's my y value that's inside of here. So I'm going to pick my y value to be 2, 1, 0, 3, 4. So I can get an idea of what's happening right around this area. Okay, so I always pick this number that would make that go to 0. So when I plug 2 in, 2 minus 2 is 0 plus 4, so that's 4. Now I plug 1 in. 1 minus 2 is negative 1. The absolute value of negative 1 is 1, plus 4 is 5. I plug 0 in, that's negative 2. The absolute value of negative 2 is positive 2, plus 4 makes 6. I plug 3 in. 3 minus 2 is 1, plus 4 is 5. I plug 4 in there. 4 minus 2 is 2. The absolute value of 2 is still 2, plus 4 makes 6. So now I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 1, 2, 3. When x is 6, y is 0. When x is 5, y is 1 and 3. When x is 4, y is 2. When x is 6, 1, 2, 3, 4, 5, 6, y is 4. Dotted line. So it's greater than. If I look at it, these x's are bigger going to the right than these x's to the left. So most likely it's going to be in here. I can pick a point just to check it real fast. That point is x is 7, y is 0. If I plug 0 in for y, absolute value of negative 2 is 2, plus 4 is 6. Is 7 bigger than 6? Yes. So that's true. So I would shade inside of here. Okay. The other way to draw these is to realize instead of it, so this is like the vertex. It's always backwards of this, negative 2, and this is the same. So I went left 2, down 3. Well, if it's an x, it's just this is the y direction that we go, and it's backwards. So I go up 2, and this is the x direction, right 4. Okay, and then it opens sideways instead of up and down. So that's another way to do these kinds of problems. Okay, graphing circles. So x squared plus y squared. Notice that it doesn't have parentheses like the next one does. That means the center of that circle is at 0, 0. So I can put a dot at 0, 0. And the square root of 9 is 3, so that's my radius. Okay, so that's my radius. And then since it's greater than, just go ahead and pick a point. Here's a point inside, 0, 0. 0 squared plus 0 squared is 0. Is that bigger than 9? 0 is not bigger than 9. So this point inside of here did not work, which means I need to shade everything on the outside of here. So everything on the outside of this circle is shaded. Okay, and now I'm going to graph the next circle. And it's going to go left 2, up 3. Okay, so I'm going to go left 2, up 3. That's the center. Square root of 9 again is 3, so I go 1, 2, 3, 1, 2, 3. Oh, these should have been solid lines. So should you do that on your paper? Just tell me that this is solid, or if you do a solid one and it's really supposed to be dotted, put a line to it and say this is dotted. Okay, so that I know that you understand that it's supposed to be dotted. Okay, all right. So I came to negative 2, 3, up 3, right 3, down 3, 1, 2, 3. We make a circle. Okay. Now this one says it's less than. So I pick this point right here. X is -2, y is 3. If I plug those in, -2, +3. So that makes 0 squared plus 0 squared. Is it less than 9? Yeah, 0 is smaller than 9, so I'd shade inside of here. Okay? So the only place where these two intersect is inside of this circle. Okay? So this region is the solution to this system of inequalities because it is shaded for both of them. Okay? So that's that kind of a problem. So that's the end of the notes for that section. Hopefully it goes well for you. Good luck. Oh, just a quick thought. The problems for this section, page 540, that actually starts on 544. 13 through 19 odd, 21, 22, 27 through 32 all, 35, 41, 43, 47, 53, 54, and 57. Okay, so that's the problems for that section.